Saving money. Money is something we all want, and sometimes we have big goals that we need to save a lot of money toward so that we have enough when the time comes for the event, such as college or retirement or Christmas, whatever it is that you need a bundle of money for. We want to look at some of the formulas that we have for saving money. The first one is saving a lump sum to get some goal amount. So if we use the general compounding formulas, we had one that was solved for A, and it was present value times 1 plus r over n raised to the nt power. You can see this formula is solved for the present value. So this formula will help you answer the question, what lump sum do I start with? And that would be the amount of money that you need to put into an account for a long period of time so that you have the amount you're after when you finish. And we have an example, and it's for college, just below. And you can also think about an example for saving up for a vacation, and say you know it's going to cost you and your family $10,000 to vacation in Europe for a month. And you have big dreams, so you want to see, well, how much money do I need to put away now so that I'll have $10,000 in, I don't know, say 5 years? And this formula will help you find the answer to that question. And so let's look at each piece of that formula. So the PV, that's our same old present value or starting amount. And then the A, that's the ending amount. The R is the rate as a decimal, as before. The N is the number of compoundings. And remember, on our last time when we used this formula, we came up with all of the different n's that you might have. You could have n equals 1 for annually, n equals 2 for semi-annually, n equals 4 for quarterly, and then you would have 12 for monthly, 52 for weekly, and 365 for daily. That's review. I'm hoping you remember those and how we find them. Remember, think about how many times the compounding will happen in 1 year, and then you might be asking, if it's quarterly, how many quarters are there in a year? And the answer is 4, and that gives you your value for n. Then finally, the last variable is t, and that stands for the time in years. So I can show you this formula that we started with, the A equals PV times 1 plus R over N raised to the NT power, and I can solve it for the PV, this PV here, simply by dividing both sides by whatever is being multiplied by the PV. In this case, 1 plus R over N raised to the NT power on both sides. So if I do it on the right-hand side, I have to do it on the left-hand side as well. And it's complicated because it's a formula, but it's our simple math rules that we're following here of equality. And meaning, if you have an equation, two things set equal to one another, what you do to one side you have to do to the other to keep the two sides equal. So here, if I'm trying to keep this equation equal, I divide both sides by this 1 plus R over N to the NT. On the right-hand side, it reduces to 1. Anything over itself is 1. And I'm left with the formula that you see on the left. The PV equals A over 1 plus R over N raised to the NT power. Now that's a pretty simple rearrangement of our variables, and so that's why I wanted to show you that there's nothing new. It's our same old beloved formula that we've been using to find compound interest, but here we just have it solved for a different variable. And so that makes it easier for us. If we're trying to find the ending amount, we look for the one that has A equals. If we're trying to find the present value, then we look for the one that has PV equals.